3PP-R is a novel virtual reality display and interaction technique. The core idea is that a third-person miniature world floats in the air in front of the user. When the user turns, the display orbits around the user. To minimize simulator sickness, we also include a static first-person reference world. 3PP-R allows the user to turn around without losing sight of the third-person avatar. The strength of a third-person view is that the avatar's movements can be manipulated without simulator sickness. The fundamental problem we are solving is seamlessly combining three virtual reality features: natural body interaction, ability to navigate large virtual spaces, and minimum cy-bersickness. In previous works, applications use first-person perspective and steering locomotion, which might cause large amounts of cy-bersickness and fail to navigate virtual spaces larger than the real interaction space. To tackle this, avatar teleportation or world-in-miniature approach is used, but at the expense of spatial orientation or a continuous interaction flow. Some games like Lucky's Tale incorporate a traditional third-person approach, and some others like Front Defense Heroes combine first and third-person perspectives. However, these methods prevent natural body movement as the user's rotation is always restricted to keep the avatar in sight. Unlike these methods, our system 3PP-R enables all of the features together. We think it's a solution to this crucial problem and will enable developers to utilize modern virtual reality headsets to their full extent. So let's take a look at how 3PP-R achieves this. A virtual third-person display, which consists of a world-in-miniature game world and a third-person avatar, hovers in front of the user. Avatar rotation always follows the user rotation, while the miniature world does not rotate, but only orbit the user by translation. This allows 360 degrees of rotation for the user, without losing sight of the avatar. In order to create this miniature, simply scaling down the 3D world was not desirable, as a scaled game world would perform poorly in physics simulations, as well as baked light mapping, and also might be incompatible with any third-party assets. So instead, we created an illusion. We manipulated the view matrix of the camera by increasing its scale factor to make everything appear smaller. Then we used this scale to calculate the camera's position relative to the avatar's position by using head-mounted display's projected direction, its elevation, and the world's up vector. This calculation also includes colors to adjust how far the camera will be away from the avatar, as well as avatar's elevation from the first-person ground plane. This ground plane is a reference world surrounding the user, also called an independent visual background or an IVB. Previous research has shown that including an IVB reduces simulator sickness. Additionally, we utilize the cutout shader to restrict the display volume so that the large virtual worlds will not be penetrating the user's body volume. In order to verify our approach, we conducted a user study in which the participants were tasked with collecting a number of waypoint spheres inside a virtual maze environment, both by using first-person perspective and 3PP-R. The results of our experiment showed joystick locomotion causes significantly less cy-bersickness in 3PP-R than first-person perspective, while first-person perspective causes a stronger feeling of embodiment. We also conducted exploratory analysis on other measures, but found no significant differences. To demonstrate that 3PP-R scales to rich and dynamic interaction, we developed a game prototype including several interactions. The first one is simply dodging projectiles by sidestepping. This shows agile exaggerated locomotion and the ability to animate a death animation for the avatar, which would cause a nauseating viewpoint movement in first-person perspective. This was followed by a winding staircase, demonstrating viewpoint rotation and vertical movement, and hovering platforms to demonstrate exaggerated jumping. We also had punching targets that show slide-to-target exaggerated punching using hand tracking. Next up, bar swing. We implemented this by temporarily making the avatar a physics-based ragdoll simulation, swinging using hand tracking data. Together with the exaggerated jumping and punching, this demonstrates 3PP-R's flexibility of user-avatar movement mapping without taking the viewpoint control away from the user. Finally, leaping onto an enemy from high ground and fighting waves of enemies in an arena, which demonstrates the simultaneous combination of multiple interactions. Projectile dodging, bar swinging, and the final combat were the most liked interactions. In general, users enjoyed dynamic and non-conventional movement like swinging arms in the bar swing challenge. Participants generally stated that they would like to experience more variety of dynamic movement, like crouching, flying and swimming. 3PP-R is ideal for this kind of motion variety. Also, none of our participants reported any experience of nausea during the study. In future work, we plan to investigate the design space of 3PP-R interaction more comprehensively. This includes testing new virtual display types instead of world miniature model, or measuring presence over other display techniques. In summary, 3PP-R enables natural movement such as turning around physically in third-person virtual reality. Our study shows that joystick locomotion causes little or no simulator sickness in 3PP-R, and our game prototype demonstrates versatile avatar movements such as ragdolling and swinging on a bar.